Do you know, once upon a time at Indian Museum faced a power cut. Soon after the power cut, the guard took two of his torch and went inside the museum. As soon as he enters the museum, he switches on his torch, and what did he saw was something extraordinary. Any guesses what did he saw? He saw alternate dark and bright pillars of beam of light forming on the wall of museum. He thought it's a ghost behind all this. He got scared and gone unconscious. What do you think? Was it really a ghost behind all this? If you are thinking yes, then stop right there because you are thinking wrong. What watchman saw was nothing but a physics phenomena known as interference of light. We know that light is nothing but a wave. Let's understand it using a principle known as principle of superposition of waves. According to principle of superposition of waves, when two or more waves interfere with each other, the resultant amplitude is the vector sum of the amplitude of the individual waves. Here are two waves, wave A and wave B, which are in same phase. Let the amplitude of wave A be A1, let the amplitude of wave B be A2. Notice these waves are in same phase. According to the principle of superposition of waves, the resultant amplitude of the two waves interfering with each other is given by the formula R equals square root of A1 square plus A2 square plus 2A1 A2 cos phi. R is the resultant amplitude. Now what is this phi? Phi is the phase difference between these two waves. As wave A and wave B are in same phase, the phase difference between them is 0 degrees. So phi equals 0 degrees. Thus the resultant amplitude will be R equals square root of A1 square plus A2 square plus 2A1 A2 cos of 0 degrees. As cos of 0 degrees equals 1, R equals square root of A1 square plus A2 square plus 2A1 A2, and we know that A1 plus A2 the whole square is equals A1 square plus A2 square plus 2A1 A2. Thus the resultant amplitude becomes R equals square root of A1 plus A2 the whole square. As square and square root cancel out each other, so finally we get resultant amplitude as R equals A1 plus A2. According to the formula, the magnitude of resultant amplitude is larger than the amplitude of individual waves, and it will look something like this. The resultant wave C has larger amplitude compared to its individual waves. This is called constructive interference. Now let wave A having amplitude A1 and wave B having amplitude A2 be in opposite phase. As you can see, the wave A and wave B are in opposite phase. The phase difference between them is 180 degrees. That is phi equals 180 degrees. When these waves interfere with each other, the resultant amplitude will be R equals square root of A1 square plus A2 square plus 2A1 A2 cos of 180 degrees. As cos of 180 degrees equals minus 1, thus R equals square root of A1 square plus A2 square minus 2A1 A2. And we know that A1 minus A2 the whole square equals A1 square minus 2A1 A2 plus A2 square. Therefore, R equals square root of A1 minus A2 the whole square. As square and square root cancels each other, finally we get resultant amplitude as R equals A1 minus A2. According to the formula, the magnitude of resultant amplitude is smaller compared to its individual waves, and it will look something like this. Here Wave A and wave B having same amplitude and same wavelength are in opposite phase. After interference, it will look something like this. Ooh, the wave has gone. This is called destructive interference. So we conclude that dark and bright pillars of beam of light seen by the guard in the War Museum was due to interference of waves. The dark pillar was due to the destructive interference, due to which the intensity of light decreased, whereas the bright pillar was due to constructive interference, due to which the intensity of light increased. Hey, wait a minute. We know that light is a wave, and wave is nothing but an energy. And we also know that energy can neither be created nor be destroyed, but can transform from one form to another form. Then where did the energy from dark pillar had gone? Was it really a ghost? Ha, no. Of conservation of energy, energy transfers from one form to another form. This means that the light from the dark pillar had ran away and had hidden somewhere else. But where? Wait, we didn't observe the bright pillar properly. Is the missing light hiding at the bright pillar? Intensity of a wave is directly proportional to the square of the amplitude. As both the torch are having same amplitude and intensity, let's take the intensity of individual torch Bi and that of bright pillar BIR. I is directly proportional to square of the amplitude. Let's take this as equation 1. IR is directly proportional to square of the resultant amplitude, where resultant amplitude is the sum of the amplitude of each individual wave, that is A equals A plus A. Therefore, IR is directly proportional to A plus A the whole square, which gives you 2A the whole square. Therefore, IR is directly proportional to 4 times A square. Let's take this as equation 2. Now, dividing equation 2 by equation 1, we get IR divided by I equals 4 times A square divided by A square. So finally we get IR equals 4 times I. This means the intensity of light at the bright pillar is equals 4 times the intensity of light of individual torch. Busted. So the missing light was hiding at the bright pillar. Now I'm gonna show you a real demonstration of interference of waves.